So next up we have another session with Dr. Megan Everett. She's the moderator for this upcoming panel. She supports the ISS chief scientist in providing leadership and support for science performed on the ISS. She started her NASA career in 2007 as an intern in the exercise physiology laboratory and conducted several ISS and analog research experiments focusing on human performance and optimizing crew health for ISS and exploration missions. Prior to her current position, Megan provided crew health support as the ISS program crew health and countermeasures system integrator. Please join me in welcoming the Dr. Megan Everett and her esteemed panelists to the stage.
All right, well, thank you very much for that great introduction. I am really excited, actually, to be here to introduce this panel. And as you all heard in that great introduction, my background is all in human physiology and performance in spaceflight. So again, super excited to hear from this group. And today you're going to hear about kind of the work that we do from this group to enable human presence in space, as well as some of the benefits to health and human performance on the ground. So we have a great panel out here today. We've got Nancy Fleming from Exploration Medical Capabilities that'll talk about some of the technical demonstrations. Dr. Sherry Uber, who will talk about some of the research integration that is unique to human spaceflight. Dr. Kristen Farb, who kind of is going to give an overview of the Human Research Program, and Dr. Sandra Whitmire, who specializes in some of the behavioral health and performance. Again, this is a fireside chat, even though I'm not sitting here. We kind of had some shortages of mics, but I really want this to be an organic discussion with this great and fabulous panel. So we're going to kind of let them talk and talk through some of the just unique aspects of human spaceflight. So I'm going to ask Dr. Kristen Farb to talk first and just give you guys a bit of an overview of what the Human Research Program does.
Thank you, and thanks for having us for this fireside panel, maybe. So yes, I'm Kristen Farb. I'm the Deputy Chief Scientist at the Human Research Program, and we focus on the human, as the name of our program says. And so that really means, how do we enable crew for exploration? So thinking about crew health, crew performance. And before I really go into any detail about that, I really just wanted to put up front the importance of partnerships. And so as we start thinking about exploration, as we start thinking about the mission of our program, we can't do it alone. And so working with our agency partners, with BPS and ISS program, ISS National Lab, our international partners, our commercial partners, other government agencies, this is really going to be crucial for us to make sure that we meet our objectives, make sure that we are meeting our mission goals. And so we're really happy to be here talking about the Human Research Program. And so we really focus on exploration needs for our crew health and performance. So we're very Artemis driven, we're very Mars driven. And what that means is these unique space flight hazards that are associated with space exploration. So in addition to microgravity, we think about space radiation, galactic cosmic radiation. We think about distance from Earth. We think about that time and space. We think about isolation and confinement. We think about the environment. So not only just radiation in the environment, but say, for example, if we have a surface mission, what is the impact of, say, lunar dust or Mars dust? So all of these different hazards we really need to think about, and we do research to make sure that we are making sure that our astronauts are as safe as possible when we're doing these exploration missions. And so that's kind of just a high-level overview of what we focus on for the HRP mission.
That's great, thank you. Can you talk maybe a little bit about how you're using ISS as a platform and some of your plans to not only use ISS, but also transition to some of the commercial development capabilities and how you see that working for your group?
Yeah, and maybe I'll start with that, and then I think that we can all have a story to tell about the importance and the critical need for having ISS as an analog for us. And so ISS is really a great way for us to study the impact of microgravity. Sure, we can do parabolic flights, we can do a number of these terrestrial analogs that mimic components of those spaceflight hazards during exploration. But the International Space Station, or research in low Earth orbit, so even in the future with CLDs, are going to be really critical for us to really understand that hazard of microgravity and what does that do to the human body. And I think all of my colleagues here can speak specifically to some of those research interests.
Okay, sure, yeah. I can share a little bit about that from the behavioral health and performance side. So in our research group, we are concerned about the psychology of spaceflight and really thinking about those future missions, those extended missions, like Kristen said, to Mars or to the lunar surface. And we've learned a lot through ISS. We're continuing to learn a lot about the human response and weightlessness, that level of isolation and confinement, how astronauts and teams come through that, what psychological support services maintain their morale, keep them connected to home. Where CLDs, I think, can come into play with some future research is, given that ISS was developed to be in low Earth orbit, how can we understand that human response of isolation and confinement in the microgravity environment? And so CLDs providing kind of a test bed, an isolated confined test bed or analog in low Earth orbit would really provide that unique opportunity. We could mimic more of that smaller volume within the spaceflight system with astronauts themselves. And so that's an exciting potential platform down the road that I think we're hoping for.
For exploration medical capability in the human research program, we use the ISS for technology demonstrations. And the purpose of those demonstrations is to, we purchase commercial off-the-shelf medical equipment, and the idea is to get multifunctional small components and test them in the microgravity environment. We're particularly interested in the equipment that is to do in situ lab analysis. Right now with the space station close to Earth, we can do that analysis on the ground, and that's terrific, but in preparation for going into deeper space, we need to be able to have that capability to do in situ lab analysis and diagnostics. And so the technology demonstrations that we perform are really about whether or not this equipment can operate in a microgravity environment. And so we look forward to the several years ahead of us with using the microgravity environment that the ISS has, and we are looking forward to continuing those technology demonstrations in the CLD environment as well.
Great, thank you. Bringing it back to some of those technology demonstrations, could you kind of give some examples of some of the specific things that you're looking at with those technology demonstrations, and maybe even how they relate to the ground and some telemedicine, the work that we do on the ground, and just kind of understand what data we need in flight that we currently do not have right now to enable exploration beyond low Earth orbit?
Sure. Just a couple of, let's see, 2 technology demonstrations ago, we flew a device called the HemaQ device. And it was the first time that we had done blood analysis in microgravity. Actually, that device is on display downstairs in the NASA booth, if you want to take a look at it. That is the device that was flown, that the astronauts performed the test on, and we learned some really great things about that. First of all, we learned that initially, operating that device, our procedures were not exactly the right way that they needed to be, so we regrouped really quickly and we reran that technology demonstration a few days later, and we found that we actually could analyze blood in space with that device. And so again, these are commercial off-the-shelf devices that we modify slightly so that they can so that they can work in the, we can test them to see if they're working in the microgravity environment. So that was what we did with the HemaQ. About 2 years ago, This past year, we flew an Our Health technology device. So these are multifunctional. The Our Health device has multiple readouts that it has. It has an EKG, it has blood pressure, it has ports for plugging in peripherals, and so we tested the Our Health device as well, and it worked really great in microgravity. The reason for these technology demonstrations is, as you know, we need to make sure that we have the capability to do these things in deep space. However, we work really closely with a lot of the military and in field, and as you heard earlier, that CSA is very interested in remote and austere environments to help the folks, a lot of their population. And so we look for partnerships in those areas that are looking for remote and austere medical care. And those folks, those entities are looking for the same type of multifunctional, small, compact, easily available devices that then you can have telemedicine, as you mentioned. I think the pandemic really helped move forward the whole telemedicine environment. And so these remote components enable telemedicine as we have long distances to take care of folks.
Great, thank you. One more question related to that. So on ISS, we have a lot of ground-based expertise, and we have flight surgeons that can pretty easily get data on crew health and kind of like give real-time medical advice. Can you talk about maybe some of the challenges with these technical demonstrations as far as we expand beyond low Earth orbit and we don't have these ground-based expertise or maybe even communication delays? Can you talk about some of the work that you're doing to kind of develop how we get that information to the crew members and how we provide that continuous astronaut care?
That's a great question. Thank you for that. Yes, as we move further into deep space, our paradigm for how we take care of crew today needs to be adjusted a little bit. Right now, as we mentioned earlier, we have got terrific crew support and flight surgeons on the ground who are taking very good care of our astronauts. As we move further, that paradigm should probably change a little bit so that the crew can take care of themselves a little bit more and adjust the expectations of the operations environment. One of the other objectives or initiatives that the exploration medical capability element is moving forward is this concept of progressively Earth-independent operations. And we use the ISS as a test bed for trying to get us, take those first steps towards more Earth-independent operations, especially in the medical environment. But particularly, we're addressing that in the entire crew health and performance environment. In fact, the new NASA Office of the Moon to Mars office is enabling that as well.
Can I maybe add to that is it's not even just technology demonstrations that we really are needing to get to the station. And I think anybody who's done research on the International Space Station knows how complicated it is to actually implement these plans. There are groups completely dedicated to how you do safety, how you do quality control checking, all of the moving parts. How do you deal with slips? Crew sign up for certain research, and that science is so important to us that it takes a whole team. And if it's okay, I would like maybe Sherry to even kind of speak to, because I still don't even understand the complexities of what it takes to really be successful in getting a lot of our science up onto station.
Yeah, so we have a great team that does a lot of the work, that does all of that integration and implementation. They really work with the investigators themselves and implement all of the amazing research that HRP does, from the technology demonstrations to behavioral health to some of the human performance measures that we collect. As we move forward, we have ISS that it's kind of our current model, and we work forward with that. And our group in particular integrates all of the human research that happens on the crew, not just the human research program, but the international partners as well. So we integrate all that because you're taking all these measures on a human themselves. So you want to look at overall the impact of what you're doing to the human, from crew time to institutional review board requirement type things to blood limits. So if you have 20 studies that want blood from a crew at a particular window, you can't necessarily take a huge volume of blood. So we have to do a lot of integration and ways to maximize that science and minimize the impact on the crew. So that's just the crew focus. But then we interface with all of the different groups within NASA and the ISS program, from safety, as Kristen mentioned, to operations, to payloads, getting all of this hardware up in space. It's no small feat. But as we're moving forward, we're excited to continue with ISS, move on to Artemis, but also incorporate those private astronaut missions and the CLDs as well. So we're working the logistics and the pathways forward on those as well.
Thank you. And yes, as I said before, I did a lot of human research program work in my previous life, and the integration office does an absolutely amazing job. And one of the things I do really want to highlight is at this conference, we talk about a lot of research and development. And one of the very unique things of human research is your data points are actually coming from the crew members. And that means that you have very limited data, you have very few crew coming up and down. So every single data point is a one-time collection. So I was wondering if you can talk about maybe some of the pre-flight preparation and operations that you do with the crew members, and the crew members' involvement in this too, because I know historically they want to know all about their health data and they really want to expand presence in space. So could you just comment a little bit on crew interaction and some of the pre-flight work and post-flight work that you do as well? The experiment doesn't just end when the flight ends. There's a lot of post-flight testing that we do to follow up, to look at recovery and a lot of things.
Yeah, no, that's fantastic. The crew themselves are very engaged, and we love their participation. For human research, it's all voluntary, so we show them a lot of options on things that they could participate in. They pick what they're most interested in, and then we start probably about a year before flight. We ask them what they're interested in. About 9 months before flight, we really start doing data collections and interacting back and forth with them. We not only do data collections, we do training, so we prepare them for some of the activities that they need to do during flight, giving them some trainings on how to use ultrasound or how to do particular blood collections, those types of things, or if there's experiment-specific activities that need to be done. So we do training. We provide on-console support, so when they're doing those science activities, we have people on the ground ready to support and help them if they have questions or if they're in need. And then we follow them through flight. Post-flight, it's probably one of the most exciting times when they're coming back, because we do some immediate testing right when they return, just to see if we can get as much data as we can about that recovery process post-flight. Then we continue to track them for probably an average of 9 to 12 months after. Some studies go 2 to 3 years after we continue to take those data collections. During this whole time, we're constantly in contact with the crew and taking responses and inputs as we go back and forth, and then providing the crew the input on their results and how that fits in with the study itself.
Great, thank you.
Meg, could I just maybe even add a little bit to the data that we're talking about?
Absolutely.
We think that this is actually a national treasure, like being able to have data from astronauts that have flown all the way back to like even early exploration Apollo days. And we actually at the Human Research Program, we have it's a bit dated, so it's under some construction, so bear with us. It's basically a life science data portal where people that are interested in human research, they can actually come in and request some of the data that we've collected over the several years that we've been doing this. And not only data, but we're actually going to be soliciting in the future for some of the tissues that we've collected over the years as well. It's called the Tissue Repository. And so really what I would like to do is, while first patient-size were under construction, but as we continue to modernize our data interface, our data dashboard for requests for data, is for people to start thinking about how would you use astronaut data, how would you use data to help us with our mission, to help with the ISS program mission, to help with the NASA mission, our international partners. Like, how do we think about the data that's out there and the research that we need to do for exploration, and also how do we use space for benefits on Earth?
Yeah, that's a fantastic point, and open data sourcing is something we really want to start working towards and making that available. So please reach out to this group if you do have questions about human research data and what is available. We have just a few minutes left, so one thing I do want to address is the behavioral health component of this just a little bit more. And so as you all know, when you're separated from your family or when you don't get to talk or see them, it is tough, right? And so we have a lot of great communication on the ISS, but we also do a lot of behavioral health studies. And so I was wondering if, Sandra, can you talk a little bit about that, and then maybe some of the unique challenges that we might not have on ISS as we look to expanding human presence in space?
Great, thanks, Megan. Yes. So the behavioral health and performance side of ISS, as mentioned before, it's really well supported. We have a great team on the ground that supports the crew, supports their family. They send crew care packages to the crew. They have real-time communication. Now there are challenges, of course. It's a high workload environment. So we do look at helping them maintain their sleep, helping them stay aligned with their circadian rhythms. There's a discussion a couple days ago about lighting and how important that is. So the stressors we feel now on the ISS, or that we try to help the crew with, are a little bit more understood. And again, there's a robust team on the ground. And then of course the astronauts themselves, the crew themselves, are amazing individuals who are really there for that larger purpose of supporting their team and fulfilling the mission. But when we think about, as we're fleshing out these scenarios on the lunar surface, it does change the paradigm, as has been discussed before. So part of what we're talking about are distributed teams, across, eventually across the gateway, across lunar surface, across mission control at home. And so part of what we look at are the team dynamics, the high tempo schedules that the crews will face on these lunar missions. Extended stays are going to introduce more radiation exposure, so we're really trying to understand that as well. And then as we look at Mars, that prolonged isolation and confinement, that physical separation on a mission of 2.5 years, that physical separation with loved ones at home, and the isolation and confinement in a small volume with the same team of 4 to 6 people. I think some of us, having gone through the isolation during COVID, can understand more and appreciate more how challenging this can be, and then that reintegration when the mission is done, helping them kind of come back and get situated again. I know for several of us, I know that could have been a challenge too as well with COVID, kind of easing back into society. So these are the things that we're looking at. ISS has just offered a wonderful platform, again, to understand the crew member experience and that level of isolation and confinement, that high tempo, closed environment, how we can support the crew. But we're expanding more broadly, looking at increased isolation in other environments, and hopefully more to come on that through the work with our partners.
Great, thank you. So we're going to shift now and take some questions from the audience, and I think Janty is back there somewhere if you have any questions for us.
Hello, yes, testing. All right, so the panel has mentioned several times about the enclosed environment and the longer and longer durations of these missions ahead. So there is a question about, is HRP thinking about the microbial environment and how it might interact with the humans on board and potentially evolve?
So, yeah, I think this is right up your alley.
So, so there's a lot of work that's being done on microbial monitoring of the spacecraft environment itself. And as we bring on new programs, I know each of the different groups has their own methods of doing the microbial monitoring of the different environments. It's very similar to what we're doing terrestrially, doing sampling and evaluating what's there and looking for particular bacteria and microorganisms of concern. So yes, that's being done.
We actually even have online, and for those that are interested, they probably have our emails, they can reach out to us. We have these evidence reports, so if they're really interested in the technical details about that host, microbiome, microbial interaction, we can absolutely point them to the direction of a lot of the evidence from the data and the science that we've collected over the past couple of years.
Thank you. And I should have reminded everyone in the beginning, but I didn't. If you have questions, please put them into the app so we can work through those, and we'll get to as many as we can.
Here's another question. The panel has mentioned many times the importance of partnerships in really addressing the gaps and challenges of future space exploration. How does someone go about partnering with HRP to solve these space exploration challenges? What are some of the ways they can get engaged?
A lot of this is organic, just reaching out to us. I know, for example, we've done a lot of work with BPS. I think tissue engineering, microphysiological systems is a buzzword or a buzz phrase that's been mentioned a lot over the last couple of days. And so those were examples of how some of these partnerships kind of came up organically because we had a lot of commonalities. It's really about these kind of activities now where we are here, we want to talk to you, we want new ideas, we want people coming up to us with thoughts on how we can work together. So you can just reach us in the hall or email us. Jancy, who's actually asking the questions now, is one of our partnership gurus. So if you really are interested, particularly in international partnerships or commercial ideas with HRP, Jancy back there is going to be your go-to, but any one of us would be happy to hear how you would like to engage with HRP. That's actually why we're here, is we really want to start to really figure out how we're working together as a community on our space exploration missions.
And Kristen, did you want to mention our websites where folks can take a look at?
Yeah, absolutely. It's also under construction with the new modern data and our interfaces. Everything we want to do is we want to update and modernize our resources. And so absolutely, the website is a great place to learn about the hazards and the types of research that we're very interested in and how you can connect with us. But I absolutely know that you have our contact information, and we're here for some of these organic conversations.
Thanks. Could you also maybe talk briefly about your funding cycles and how you would apply to those, in addition to just having the conversation, just getting a foot in the door?
Yeah, and actually, maybe I'll have Sandra talk about how she thinks about the funding cycles, and I can expand on it, but I think maybe an actual real-life example from a behavioral health would be good.
Sure, yeah, no, it's a great question. So for researchers who might be interested in reaching out, we do have opportunities throughout the year. These have been a bit on hold the past couple of years, but starting up again. One in particular is called the Omnibus Opportunity, especially for new researchers. That tends to come out 2 to 3 times a year. It's about a year, thank you, yeah, about 2 times a year for about a year's worth of funding to do these starter research types of studies. They don't facilitate a spaceflight study. Spaceflight research takes much longer, but as a precursor to spaceflight, if there's a lab investigation, a smaller study that you think is important, that you've gone to the website, you've learned about the risks of human spaceflight, and you feel like you have something that might address what you've read are gaps, look into the Omnibus opportunities. I think the website is the NSPIRES NASA website. If you Google that, it'll take you to the NSPIRES portal, and you can register there and then look for those opportunities. I think there's one on the horizon very soon for an Omnibus. We also have what we call our flagship opportunities, also about a couple times a year, and so you'll see a focused research question that might be released. These tend to address a human system, so maybe the psychological side or human factors or physiology, And those provide 3 to 4 years of funding to help us buy down risk. But those are opportunities, again, available through the ISSRDC website. Probably within the next month or so, I think we're going to have one come out, and then maybe later this year or early part of next year as well. So to just encourage folks, look at HRP online, look at the ISSRDC NASA website.
Those are solicited opportunities, but we're also a firm believer in, again, recruiting new ideas, new people, new backgrounds. We've been hearing a lot throughout this conference about people's background and stories and perspectives influence their science. And so we really want to capitalize on some of the other NASA agency opportunities as well. So small businesses that are interested in getting into space flight, maybe they have technologies that they never would have thought in a million years that they could have actually used this for space flight. We're very interested in talking to these companies. Minority serving institutes. There is a program at NASA called MUREP, which is, I'm not really good at remembering what all the acronyms stand for, but they are, it's really the outreach on how do we engage, how do we interface with a lot of these minority serving institutes to encourage them and take advantage of some research or funding opportunities and outreach opportunities as well. So, so we're also trying to capitalize a lot on some of the resources that NASA offers for new solicitations or funding.
And if I can put just a quick exclamation point on that one, Kristen. For the small business initiatives, the SBIRs, exploration medical capability plays in this arena, advocates and uses this tool every year, multiple times. And an example of that has come to fruition is again, our technology demonstration for the our health compound medical technology that is also located in the booth downstairs that flew. It started out as an SBIR component working with XMC, Exploration Medical Capability, and HRP as a small business initiative, and that got refined over a few years, and then it was strong enough so that we were able to evaluate that in a microgravity environment. So the small business initiative is really important.
Great, thank you very much. So with that, I think we are about out of time, but I want to again thank you all for coming and listening to this great panel. I 100% encourage you to go say hi and talk with all of them at the booth downstairs, and enjoy the rest of the conference, and thanks for listening on the last day.